Hello everyone, welcome to another Quad Education Test Prep Fundamentals video. My name is Tom, and today we're going to be talking about a really interesting, very exciting topic called expected value. This video is a follow-on to my basic statistics and averages video, so if you haven't seen those, go over and take a look. And whether you're coming back from taking a look at that or you're already comfortable with averages and stats, let's take a look at expected value.
Okay, expected value. Okay, you might see this term and think, expected what? What are we expecting and why is it valuable? What's the value to it? So don't be put off by this fancy term because the concept is pretty close to the things that you already know. In fact, I'd say a lot of the difficulty associated with expected value questions is the fact that the test asks you about this odd, unfamiliar topic, and that makes it easy to get intimidated. So instead of a question just saying, hey, can you kind of just find the average of these couple of outcomes we're giving you, it says, what is the expected value of the discrete set of outcomes listed in the table below? And it sounds much scarier, but really those two questions that I just asked are looking for the same thing. And so let me prove that to you. So take a second to see if you can solve my little example I put together below. Okay, let's see what we can do. It says, if you have 5 cards that say 1 point, 3 cards that say 2 points, and 3 cards that say 3 points, what's the average point value for each draw of a card? So random draw of a card, what's around about how many points you're going to get for that draw? And so if we're going to calculate an average, which is what this is, like I said, we say, okay, referencing back to our averages video, that's the sum of the numbers divided by the number of numbers. And so we know, first of all, 5 plus 3 is 11. So we've got 11 cards. So we say 5 times the number of 1-point cards we have plus 3 times the number of 2-point cards we have plus we're going to say 3 times the number of 3-point cards we have. And that's a total of 11 cards. So that's going to be 5 plus 6 plus 9. And 5 plus 6 is 11, and 9 is 20. So that's going to be 20. And we have 20 over 11. And for the sake of simplicity, I'm going to say I divided this already with my calculator separately, and I got 1.81. So basically our average draw for a card is 1.81 points. So really not that bad. But I will say the interesting thing here is that the expected value of this system is not necessarily one of the discrete values. And discrete is just like a fancy, complicated math term that means specific and whole number. So a discrete value would be 1. And if you had discrete values 1, 2, and 3, you wouldn't have anything in between. So it's exactly 1, exactly 2, exactly 3. That's to say, there isn't actually a 1.81 or whatever card in the deck, but that's still the expected value of the system. And that's interesting, but, not really that interesting, I suppose, when you look at it from the perspective of it being an average. If there's no reason an average needs to match up with a specific value of the input value, then it shouldn't really matter that the expected value does that as well. But it's still definitely worth mentioning for when this gets more complicated that it's okay that, the expected value isn't any of the values in the system. In any event, moving on, in case you were curious, here is the traditional equation that you will see for an expected value. And I honestly wouldn't worry too much about the values in the limit part right here. The sigma right here just means the sum of the values in the set. So EX, the expected value of X in a system, is equal to the sum of, which is the sigma part, of the products, that's our multiply one by the other. Xi is like an individual event in the system times the PI is the probability of the event in the system. So like if you just want to do the same example we previously did just in the context of the technical probabilistic way that they do absolute value sometimes, we have 1 point for the first one times, this is 5 out of 11. Sorry, not add. It's times 5 out of 11 plus the 3 cards that say 2. So it's 2 points times 3 out of 11. And we're going to add that to 3 times 3 out of 11. And if you think about just like basic factoring and seeing what you're really doing with this over 11, that's the same thing as, 5 times 1 plus 2 times 3. I suppose I should flip that around. It's 3 times 2. It's 3 cards at 2 points, but you know what I'm talking about. And then 3 times 3 here, all over 11. Like these are the same thing. It's just In this one right here, we've distributed that times 1/11th. And in this first one, we haven't, and that doesn't matter as far as order of operations go. So just showing that those are equivalent, it's still just taking an average, just like when one of them we're, distributing the probability to each event, and the other one we're not. It's the same thing. And so that's a reasonably high-level technical discussion of expected values. We're going to do some examples now, and I think one of the key lessons that I've shown you here is just I've kept this really simple. I think a lot of people, when they try to instruct like students on this, they'll spend way too much time and make it seem way more intimidating than it actually is. But I'm saying, hey, you can explain the expected value in 5 minutes. And 5 minutes is probably better than 50 minutes, because in 50 minutes, you're just going to get confused. So this is it. Just like weighted average for some outcomes. That's expected value. Let's take a look at some examples. Okay, we've got 2 of these. We're going to look at one at a time. See what you can do with this long, scary word problem. Okay, let's take a look. So good test practice is to look at the end of the long word problem to figure out what the question is. We're saying, given that a hamburger costs 20 bucks, it must be like 2027, and inflation has really gone crazy. What is the average price that Jane can expect to charge each customer with this promotion? So how much for a hamburger? To promote the opening of her new restaurant, maybe it's just a really good hamburger for 20 bucks. Jane will run a promotional game for discounts on hamburgers, so less expensive. To play the game, customers must draw a ball from a jar containing 4 green balls marked 10% off, 3 orange balls marked 40% off, and 1 black ball marked 80% off. Each customer randomly selects 1 ball from the jar to determine what discount the customer will receive on the price of the hamburger. Given that the hamburger costs $20, what is the average price that somebody can expect to pay for a hamburger? And so what I'm going to do for this, just, sort of to call back to the percents video that I did a long time ago, is when I say 10% off, I'm going to say that 90% remains. So that's 90% of the price of a $20 hamburger. And we're going to multiply that by the probability of that happening. And in this case, I'm just going to divide eventually by the total number, just, to keep it as an average, just to show that it's still an average we're doing here. So we're going to multiply that by, and I suppose I could just take this out. So there's a 10% discount for a $20 hamburger, and that occurs 4 green balls marked 10 off. So there are 4 green, we have 3 orange, and we have 1 black. And so that's a total of 8 balls. So there's 4 green balls. We're going to add that to 40% off, so that's 60% remaining. So if you take 40% off, you get 60% left times your $20 hamburger, and that's going to be multiplied by 3 because there's 3 of those balls. And we're going to add that to the last one, which is, if we have an 80% off, that means we have 20% remaining, and that's times $20 hamburger, and there's 1 of those. And we're going to divide all that by 8. And you can do a little bit of fun stuff here. 90% of 20, that's going to be 18, because 90% of 10 is 9, multiply that by 2. So we're going to say 18 times 4 is 72. And then 60% of 20 is 6 times 2, which is 12. 12 times 3 is 36. And 20% of 20 is 4, so that's plus 4. So we have here is 36 plus 4 is 40, and 40 plus 72 is 112. And now pulling out the calculator, 112 divided by 8 is 14. So that is the average price of the hamburger. And I will definitely put in 6 here, which is the average discount of the hamburger, but that's not the price after the discount. And so I think actually if we wanted to do this, one other way, we could have said, instead of doing it this way where we add it all together and divide by 8 at the end, we could have done, 18 times 1/2, which is 9, plus, 12 times 3/8, which is kind of ugly. And then we could do 4 times 1/8, which is 1/2. And so Either of those ways will get you to 14, but whatever is more comfortable for you is how you want to do that. Okay, moving on to the next one, see what we can do with this. Okay, this guy asks, the probability distribution of x, a discrete random variable, is shown in the table below. What is the expected value of x? Very fancy words. And so what we can do here is basically just we start multiplying these across to see what their probabilities are. And we've got, and then, you know, another really important tactic is to always glance at the answers before you start doing a problem. So we've got a third, 2/3, 2, 4, and 6. And so we want to know, like we're at almost a third of the 1/3 is the outcome, and then 6 could be the outcome as well. So we look here, 0 times a sixth is nothing. 2 times a 1/12 is a sixth. And then 4 times a quarter is 1. So we've got 1/6 already. So we can go ahead and get rid of these two because those are less than already what we have as a total expected value. And then 6 times a half, so 6 times 12 is 1/2. And then 8 times a 12th is 2/3. And then we got a 0 here. And then we have 12 times a third, which is 4. So already we're above 4 for our, and maybe you're laughing as well because you know, like we're basically done now. We're above 4 for our expected value. So all that is gone, and I am done because I already know that there's only one answer that is more than 4. And we know that there's always one right answer. And if the answer must be more than 4, it's got to be that one. And hopefully there's a good lesson here for you, which is to say, did you do all the work? Did you find that it was specifically 1/3 as the expected value? Or did you know that you were in a place where you didn't have to work anymore? And so a little sneaky test strategy lesson in there for you.
Okay, that's it for this video. As I've said in videos past, I'll say it again, I love statistics, and hopefully this illustrates sort of why that is. I will also say that this is an extremely important topic to understand if you want to be successful in any sort of math-related business track, so that's your finance, accounting, economics, what have you. This is an essential topic to just basically the foundational understanding of those fields. So if you want to get into those, I would definitely recommend getting all the way understood on this topic. Anyway, if you found this material useful, we hope that you will like and share the video and subscribe to Quad Education. Thank you for watching, and I hope you have a great day.